You've probably played around with a tool like ChatGPT, right? I mean, it feels like actual magic. You ask it for a poem, an email, some code, and poof, there it is. But here's the thing, it's not magic. It's actually the incredible story of some of the world's smartest people solving one gigantic problem after another.
So that's the real question, isn't it? How on earth did we get from these old, clunky calculators to an AI that can write a sonnet about, I don't know, a toaster? That's exactly the story we're going to unpack.
Yeah, this really didn't happen in some big eureka moment. It was a journey, a step-by-step quest, really, to build a smarter and smarter machine. So let's break down that journey and look at the key breakthroughs that finally made all of this possible.
Okay, first things first. Before we get into all the nuts and bolts of how it works, we need to get on the same page. What are we even talking about when we say generative AI?
You know, at its heart, it's all about one thing, creation. For the longest time, AI was really good at analyzing things or sorting information that already existed. But generative AI, it makes stuff, new stuff that's completely original.
Probably the best way to get this is to picture one of those Russian nesting dolls. You know the ones. The biggest doll, the one that holds everything else inside it, that's artificial intelligence, or AI. It's this huge field that's been around since the 1950s, all about getting machines to think or act like humans.
Okay, so you open up that big AI doll, and inside you find the next one, machine learning. This is where things got really interesting because we stopped trying to program every single rule and instead started teaching machines how to find patterns in data all by themselves.
Now we go one layer deeper and we find the next doll, deep learning. This is super cool. It uses what are called neural networks, which are these really complex systems that are actually inspired by the way all the neurons are connected in our own brains. It lets the AI find incredibly subtle patterns.
And finally, right there at the very core, you've got the smallest doll in the set. That's our generative AI. It takes all that power from the deep learning neural networks and uses it not just to find patterns, but to actually generate something totally new based on them.
All right, so now we know where generative AI fits in the big picture. Let's talk about the first massive roadblock that engineers slammed into. It was, believe it or not, a memory problem.
See, the early models, called recurrent neural networks, or RNNs for short, they had to read text just one single word at a time. And the problem was, with a really long sentence, by the time the AI got to the end, it had completely forgotten what was said at the beginning. It just couldn't hold on to context.
And this was a huge deal. I mean, progress really stalled here. Think about it. How could you ever expect an AI to write a whole paragraph if it couldn't even remember the start of a single sentence? And then, in 2017, a research paper dropped that just changed everything.
This was it. I mean, what a title, right? Attention is all you need. So bold. In this paper, a team of researchers from Google laid out a brand new system, a new architecture that they called the transformer. And it wasn't just a small step forward. It was a gigantic leap.
So here's the genius of it. Instead of reading one word at a time sequentially, the transformer could look at the entire sentence all at once, in parallel. It used this really clever trick called an attention mechanism that let it figure out which words were most important to which other words, no matter where they were. All of a sudden, the memory problem, gone. And because it worked in parallel, it was unbelievably faster.
So, transformers gave the AI a killer memory and incredible speed. Awesome, right? Problem solved? Well, not quite. There was another huge problem holding things back. Basically, these AI models were just one-trick ponies, and they were super inefficient.
Yeah, back then, in the world of natural language processing, if you wanted an AI that could tell if a movie review was positive or negative, you had to build a whole model just for that one thing. If you wanted another AI to summarize an article, you guessed it, you had to start all over again, from scratch. None of the knowledge from one model could be transferred to another.
The solution was one of those ideas that's so simple, it's profound. The researchers thought, okay, instead of training for all these specific little tasks, what if we just trained the model on one single, universal task? Predict the next word in a sentence. Just that. Because to get really good at that one simple thing, the AI would be forced to learn everything about language on its own. Grammar, facts, context, even a bit of reasoning.
And that was a second massive breakthrough. This general-purpose understanding of language became a kind of base skill. You could then take that base model and easily tweak it or fine-tune it for dozens of different tasks. For the very first time, an AI could transfer what it learned from one problem to another, just like we do.
So now you have these two incredible breakthroughs, this powerful new architecture and this universal way of learning. And when you put them together, well, that's when you get the models that we're all using today. Let's just look at the formula.
First, you start with the engine, the transformer. It's the powerhouse that can process just unbelievable amounts of text all at once and remember all the important context.
Next, you give that powerful engine its mission, language modeling. You give it one simple, all-consuming goal. Just predict the next word.
And finally, you give it the fuel. And I mean a lot of fuel. You feed it an unimaginable amount of text. We're talking a huge chunk of the public internet, books, articles, websites, tens of terabytes of raw data.
And boom, there you have it. That's the recipe. A transformer architecture plus the language modeling goal plus a truly massive data set, that equals a large language model, an LLM. That is the technology behind ChatGPT and pretty much every other generative AI tool you see out there.
Okay, so we've solved the memory problem, we've solved the knowledge problem, and we've got this incredible formula. But let's bring it back down to earth. What does this actually mean for us in the real world? What can this thing do?
Well, this journey from pure theory to something you can use on your phone unlocks something pretty incredible. And it's not just this list of features. What's absolutely fascinating is that when you build these models at such a massive scale, they start to develop what scientists call emergent abilities, skills they were never ever explicitly trained to do. Just by learning to predict the next word, they somehow also learn to reason, to summarize, to translate, to write code. It's a general-purpose language tool unlike anything humanity has ever built before.
So, after decades of brilliant people solving one seemingly impossible problem after another, we've finally done it. We've taught machines our most human skill, our language. The only question left is, what do we want to talk about?